Hi, I'm ED-SKaR and I have an interesting toy to play with today that's missing a piece that I think I can recreate, but I'm going to have to explain at least a little bit before I get to work. And so let's go to the top-down view and have a look at exactly what this is. So what we have is a toy angle grinder. We have a handle off to the side so that we can hold it kind of like a real one, and we've got the button to activate it there. And if you hear that sound, that's the electric motor that's actually making this part spin, and this is where the blade would mount. Now, one of the cool things about this particular toy is the battery pack that powers it all, because in a way, sort of like a real one, battery pack is removable just like that and connects in, and as we find out by removing it and pressing the button, nothing happens. There is a battery compartment in here for two AA's, and so you have this AA cell that most parents have access to for the toys for their kids, but then you have this kind of battery pack that almost makes it work like a real one, and it actually spins the blade. The problem is, when I got this, the blade was missing. But that's okay, because I think I can recreate it, and I can recreate it in a different material to make it a little bit more fun. But first of all, I'm going to have to take some measurements of this and see if I can make something fit. As my skill set includes 3D modelling and 3D printing, my first thought was to go ahead and do a 3D model design and then print out a base for my blade. To start with, the mounting piece is a strangely complex design, but it actually has quite a few good features. It has some anti-rotation tabs, which may not make perfect sense at first because you think the whole thing is supposed to spin like you want it to rotate, but actually these tabs make sure that the mounting piece, which is spinning on the motor, and the blade, which is connected to the mounting piece, that the connection between those two parts doesn't rotate, and that means that when you power it on, it's not going to slip. And there's also some clips that I need to make surfaces that will attach to, and the whole thing is just really nicely done, surprisingly nicely done, given that it is just a toy. And I finished this up by making a 1mm thick disc that was slightly smaller in diameter than my blade would end up being. And the reason why it's 1mm is because I actually have some 1mm foam. And when I layer the foam pieces together, I can fill out the diameter in line with this disc with the 1mm foam, which means that at the edge of the blade it's purely foam and it's not going to ever have the chance of hurting anyone. So now that I've got that 3D modelled and then printed, this is the plastic core, as it were, of my disc. It does seem to fit on the rotating piece. I don't want to press it all of the way down, like clip it in place, because it might never come off again, and I need to make sure that I can finish making the foam and painting it before I attach it what could be permanently. But just with it pressed like halfway on, there's really no part of this that should be interfering with any of the mechanism or the shield either. Now, I did have one problem when printing this, and that is a nozzle clog, and so what I've done is painted over the entire central area with solvent weld to kind of glue the bits of plastic left together. But just to make doubly certain that it would hold, I've also thrown some epoxy over the top, mainly just on the tower and the connection between the plate and the tower, because the plate, the kind of disc part of it, seems to have come out fairly well and is nice and flexible, so the resultant foam piece should have a lot of flex as well. So let's get to cutting some of the foam. Now, this is EVA foam, and so I'll need an extremely sharp knife, and I've brought my cutting mat to protect my table. I also have, rather interestingly, this absolutely ancient and lovely compass, which I'm surprised I even had. I was looking for one of those kind of plastic things that you have in school. I thought I had one of those knocking around the house, but all I could find was this far nicer one, and I'll accept that trade. I ended up with 3 layers of EVA foam. My first layer was a solid 3mm thick. My second layer was essentially just the ring around the outside. That's a 1mm thick piece because that has to match the plastic core that I've printed. And the top layer, again I used the 1mm. I could have used 3mm here, but I chose to use the 1mm to keep it a bit thinner. And that just had a small hole cut out in the center for the tower of my blade. After cutting them out, I simply glued them together. I'm using an impact adhesive that I've had recommended to me for use with EVA foam. It requires water and pressure as well. So if you notice the 3D printer spool on the side, that is for a little jig that I made so that I could support the layers of foam and actually press them together without having the tower get in the way, and that's why I needed something with a flat surface and a hole through the middle. Next step is rather interesting because I'm now dremeling the foam, and you don't usually associate foam with being a material that's strong enough to take a Dremel to it and have it survive. But in the case of EVA foam and the correct bit for the Dremel, you can actually shape the edges of foam, you can cover over where there are gaps, and you can cut the sharpened area of a blade into it, and that's what I've done here. Now you will notice at one point that I slipped and I gouged a chunk out of the top of the blade, and that's not great. However, I think I'll get away with it because that's on the inside of the tool when it's complete. But also I can just paint it in kind of bright silver to make it look like damage to an actual blade. Not necessarily realistic, but it's a mistake that I can just about get away with. So now that I've mentioned painting, I should probably show the painting step, although to be honest it's somewhat dull, so I'll gloss over it pretty quickly. The blade got a Plastidip coat to protect the foam, it got spray paint primer, and then I painted it silver, and then I put a clear coat over the top to protect the paint. That's it. That's all there is to it. But now that that's done, it's done, it's finished, so I can finally put it together. Okay, that's done. That's painted, and my little mistakes are sort of covered up in a way to make it look a bit more reasonable. I have opted to not go for the fully realistic look. Usually if you find a blade like this for an angle grinder, it'll have a big sticker on the side with all of the information about it. I'm not going to go quite to that extent. I'm just going to have it as such, and I can finally get around to attaching it. Now I haven't test fitted this piece yet since it's come off the printer. And partly that's because when it goes on, it might never ever come off again. So I needed to build the foam. I needed to build the foam around it first, because otherwise I wouldn't be able to at all. So, the moment of truth. Let's line this up and see. If I can get it. This is the point where I realised that my sealant coat went on the inside of this locking piece, not just the outside, and so it might be interfering with my tolerances. Also, my design may have been slightly wrong to begin with. I'll fully accept that. What I might just do is quickly take a knife to some of the edges. Aha! And I think that does it. That gets it on. It's relatively tight. Let's see, can it be dropped on the floor? Absolutely. Let's see, can it be easily removed? Yes, it can. Okay, so that's an option. So I can click it into place and pull it off, which is good in case I need to repair it. But now, finally, after that little bit of faff, There we go. This is absolutely done. So, I should point out at this point that even though it has a soft foam blade and a very thin plastic core, this is not the sort of thing that I'd be using in a competitive game. But certainly something like this would be appropriate for some circumstances, certainly as a toy. Although that foam could probably get damaged if you actually went to try and cut away at something. However, I don't care about how I get to use this, I just care about having built it, which I have now done. Congratulations me, and that brings me to the end of this video. So, I'm ED-SKaR, always will be, and thank you very much for watching.